So here we have our first question that we have that we're going to add and subtract rational expressions where you have a 72 and a 27 at the bottom. Now this one's technically not really a rational expression because we don't have letters. This is just like regular fractions. But we wanted to start something off easy where we can show you that when you have addition, when you don't have anything that matches at the bottom, on how to find an LCD and how to raise to the LCD so that we can actually add these two fractions. Because the way it's written, 25 72s and 2 over 27 cannot add. So the first thing we told you is see if they match or no match, and we told you if they are not the same denominators, then it is no match. There's no trick on like we had the other guy where I can tweak this to make it look like this without finding an LCD. So once we see that it's no match, let's try to figure out how to find an LCD. You got to remember our 7.3 rules. If these are monomials, you need to factor them out completely using tree diagram. So most of you know that 72 is 2 times 2 times 2 times 3 times 3. 8 times 9. 8 breaks down as 3 2s, 9 breaks down as 2 3s. And 27, that's 3 times 3 times 3. So for us to do an LCD list, remember you write down LCD, and then you write down each of the different types of factors. Notice we have 2s and 3s. That's it. Notice I write down one of each type. Even though we have multiple 2s or multiple 3s, just write down each type only one time. Once we do that, then let's look at the number 2. See how many 2s we have here. 1, 2, 3. How many 2s do you have in this denominator? 0. So 3 versus 0. Always grab the largest amount when you're doing LCD. For 3s, notice we have 2 here. We notice we have 3 here. So again, the largest amount is 3. Alright, so then we know our LCD is going to be 2 times 2 times 2, 3 times 3 times 3. So we're going to have 8 times 27, and 8 times 27, let's see, yeah, I'll probably have to do it on the side, it's a little too much for me, 56, and that's 16, so it looks like 216. Right. So with 216 being our common denominator, let's raise each of these fractions now that we have an LCD. So take your first fraction, 25 72, and raise it to 216. But it'd be easier to look at it in the factored form. You know 72 is this. So it's easier to always look at the factored form. That way you can figure out what the extra pieces are. And we know 216 factors out as this. 2 times 2 times 2 times 3 times 3 times 3. So when you draw your boxes, one on top and one at the bottom, you can clearly see if you started your trip in Philadelphia with 5 passengers, but when you got to Boston you had 6 passengers, you can see the extra piece. We got 3 2s, 3 2s. We got 2 3s, we got 3 3s. So we got an extra piece. That extra piece would go into the bottom box. Remember how we said whatever's in the bottom box goes to the same as the top box? And to get the new numerator, you take this 25 and times it by 3 to get 75. We're going to do the same thing to the other guy. Notice that we have 2 27s. We need to raise that to the 216. But it's hard to see what would be in the magic boxes when they're not in factored form. So that's why I always say, kind of use the factored form. We know that 27 is 3 times 3 times 3. We know that 216 is this. 2, 2, 2, 3, 3, 3. So you can see you started off with 3 passengers, ended up with 6 passengers. So these are your extra pieces, your hitchhiker. 2 times 2 times 2, we could easily say it's 8. Whatever's in the bottom box, you have to do to the top box. So 2 times 8 is 16. So instead of using 25 72s and 2 27s, let's use the equivalents that we just found here. Alright, so I'm going to erase and saying, hey, this 2572 is the same thing as 75 over 216. The equivalent of it. Instead of 2 27ths, we found that its equivalent is 16 over 216. When you use the equivalents, then it's no longer a no match, it's matching. Okay? That was the whole purpose of us finding an LCD, which we did here, and raising, which we did here, is so that we don't use the original fractions, we use the equivalent fractions. The equivalent fractions have the matching denominator. So I know that 216, that this would stay 216. All I need to do is add the tops. Now, luckily this is a plus sign. We don't have to do parentheses, but if you want to, remember parentheses 75 plus 16 parentheses, and if you distribute, you'll still get 75 plus 16. And then this plus this, they're both constants, so we know we can collect. They're both positives, so we know we can add. And 75 and a 16, we're going to get 91 over 216. 91 is a prime number. You can't break that down. You cannot divide this by 2 or 3, 4, 5, 6, not even, I don't think 7 works. Maybe 7 works. I'm looking at it a little closer. I'm thinking maybe 7 works. 7, 21, 13. Yep. So this does break down. So it's not really prime. It didn't have the traditional 2s, 3s, 4s. It had 7s and 13s. So if I try to break this down as 7 and 13, you already know 216 broke down as 3 2s, 3 3s. You can see that this has no matching factors. 13 is different than a 3. 7 is different than a 2 and a 3. So there's nothing that can cancel out. We still had to check, okay? So I was a little surprised that it was 7 and 13, but that didn't really help us. So our final answer is this, because it could not reduce. So to recap, our originals did not match. We had to find an LCD. We found that it was 216 when we were comparing the 27 and the 72. We raised each of these to 216ths, and we used the equivalents to add. And our final answer for this one is 91 216ths.